Alright guys, so this is section 5.6, and there's really two theorems we're going to cover in this section. And it's the angle-side-angle theorem, and then the angle-angle-side theorem. So hopefully you've already watched that short clip kind of illustrating the two. Now I know they look very, very similar. Note that the difference here is on the angle-side-angle, the side is, I'm going to put between the two angles. Okay, and then down here, angle, angle, side. So notice the side is not between the two angles. All right, so angle, side, angle. When I say the side is between the two angles, if you look at these, notice the side we know is right here and here, and the angles we know is right here and here. This is the side that is between these two angles. Okay, now if we take a look down below, the angle-angle side theorem, so if we know this angle and this angle, this angle and this angle, and then this side and this side, it's not going to be the angle, or it's not going to be the side between the two angles. The side between the two angles would be this side and this side. And if we don't know this side, it has to be angle, angle, side. Nevertheless, anytime we have two triangles and we know two angles and one side, we know they're congruent by either the angle, angle, side or the angle, side, angle theorem. All right, so let's look at example 1 now. And we have 3 different pictures, and we want to know, can these triangles be deemed as congruent? And if so, which theorem would we use? All right, so let's look at this one. Let me see if I can draw this. It's pretty good. All right, so we have this triangle on the left and this triangle on the right. Okay, we see that this angle here is congruent to this angle here. So I have one angle we know is congruent. I see we have one side and one side, but I don't see anything else. Now, we can look at this figure and we can tell one other thing is congruent. What do we know is congruent and why? Well, we know the vertical angles, which is here and here, are going to be congruent because the vertical angle congruence theorem. So now we have two angles in one side, so we can say that they are congruent. Now the question is it angle, 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 or is it angle, side, angle? This one would be the angle, angle, side, because the side we know is not between the two angles. If the side was between the two angles, it'd be this side and this side. All right, let's look at B here. All right, so we're looking at the two triangles with all the markings on it. So these two triangles in white. Okay, so we have an angle and an angle. We have an angle and another angle. And then we have a third angle and a third angle. So we know all of the angles are congruent, but we know none of the sides are. So can we say this triangles are congruent? I guess my question is, do we have an angle, angle, angle congruence theorem? No, we do not. Angle, angle, angle is not a thing. Think if we have two equilateral triangles. Okay, so equilateral triangles 60, 60, 60. Could we have a big one like this? And then a big one like this with all angles 60? Sure we could. Okay, so angle, angle, angle is not a thing, and therefore we can't tell if these are congruent or not. All right, so let's look at this one up here. So we're looking at this top triangle and this bottom triangle. These are kind of weirdly drawn. And we see that this angle here and this angle here are congruent. And then we also see similar markings on this angle and this angle. So we have two angles, but we don't show any sides. Can we look at this figure and pull out a congruent side of both of these triangles? Yes, we can, because this middle side between them, this diagonal if you want to call it, they share this side, okay? This is a side of both of these triangles. And we know by the reflexive property that it's congruent to itself, so we do have a side. Now our question is, we have two angles on a side, is this side between the two angles or is it not between the two angles? The side is between the two angles, so we would use the angle side angle congruence theorem. All right, let's look at example 2. Now I want you to look at this, and I want you to try to figure it out on your own, and then we'll go over it. I do want to notice these arrows here and these arrows here, okay? Remember, these tell us that XY is parallel to WZ, and it also tells you that XW is parallel to YZ. You will use that in this, so think of what that tells you and try to get this done. All right, so let's look at this. So if we have XY on top and YZ on bottom, these are parallel. And then I'm going to use this line that separates them as my transversal. So it goes something like this, okay? So what do I know about this angle here and this angle here? Okay, these are alternate interior angles. And I do know that alternate interior angles are congruent when the lines are parallel, which they are. So if I look back up to here, guys, that would be angle 1 and angle 3. Okay, so I can say angle 1 is congruent to angle 3 by the alternate interior angle theorem. Okay, now let me look at XW and YZ here. And once again, I'm going to use that same transversal that goes right here. Okay, what do I know about this angle and this angle when these two lines are parallel, which they are? Once again, these are alternate interior angles, and I know alternate interior angles are congruent when lines are parallel. So if I look back up at this diagram, this is angle 4 and angle 2. So I can say angle 2 is congruent to angle 4 by the alternate interior angle theorem. Okay, well now I have two angles. I need a side. Okay, another angle won't help. I need any of the sides. So if I look at this, what I see is that this diagonal here, this is a side of both this bottom and this top triangle. So I could say that WY is congruent to WY by the reflexive property. Okay, and so then I have two angles in a side, so all I need to do is look to see if this side is between the two angles or not, and it is between the two angles, so I could say I could use the angle side angle theorem. All right, so let's look at this proof right here. All right, I'm given that AD is parallel to EC, and notice it already gives me my markings for it. That's given. And I'm also given that BD is congruent to BC, and that is also marked right here and right here. So that's given. All right, so let's go back to this here. If AD and EC are parallel to each other, what does that tell me? Let's use this as our transversal. Okay, if this is our transversal, this angle and this angle would be alternate interior angles, which means the lines would be which means the angles would be congruent. So I can say angle C is congruent to angle D by the alternate interior angle theorem. Okay, well now if I look at this as my transversal, and still these lines are parallel, doesn't the same apply for this angle and this angle? Those are also alternate interior angles with that other transversal, so angle A is congruent to angle E by the alternate interior angle theorem. Okay, now I have two angles. So I have an angle here and an angle here. I have a side here. So I have two angles and a side, which is all I need. So now I need to ask myself, is this side between the two angles? No, it is not. So it would be the angle side theorem, and I could say triangle ABD is congruent to triangle EBC. Now, some of you, if we wanted to, we could have done this angle and this angle as vertical angles as well, and just one of these two. And if you did this one and D, this one and C, then you could do angle side angle. So there's several ways you could have done this. It's just whichever way your brain works. All right, I want you to try to do this one on your own, and then we will go over it. All right, let's go over this. So the first two things we're given is that AB and AD are perpendicular and DE and AD are perpendicular. So I went ahead and wrote that in. All right, so my next question is, what does it mean to be perpendicular? Well, if these are perpendicular, that means that angle A is a right angle, and it also means that angle D is a right angle. Guys, that's just by the definition of perpendicular. Okay, well, what do we know is true about all right angles? We know all right angles are congruent by the right angle congruence theorem. That was way back in chapter 1. Right angle congruence theorem tells us that all right angles are congruent. All right, then we're given that AC and DC are congruent, so that's given. All right, let's look up here. We've shown that A and D are congruent. We've stated and shown that AC and CD are congruent. So I need another side or another angle. Okay, well, a pair of angles should jump out at you in this diagram, and those would be the vertical angles. Okay, so I could say that angle ECD is congruent to angle ACB by the vertical angle congruence theorem. Okay, and now if I look, I have two angles and a side, so all I need to know is, is the side that I know between the two angles, or is it not between the two angles? Here it is between the two angles, so I would write angle side angle with my side between the two angles, and that would be the proof for that one. All right, go ahead and try this one on your own, then we'll go over it. All right, so let's go over this. So we're first given that HF is parallel to GK, okay? And they wouldn't give you that if they didn't want you to pull something from that. So with these are parallel, and I have this as my transversal, I know that this angle here and this angle here are alternate interior angles, and alternate interior angles are congruent. So angle FHG is congruent to angle KGH by the alternate interior angle theorem. Then we're given that F and K are right angles, so that's given. And then we know by the right angle congruence theorem that all right angles are congruent. Okay, so angle F is congruent to angle K. Okay, lastly, I see that this diagonal right here, this is a side of both this triangle and this triangle. So I'm going to use that as a reflexive property. And then I have two angles and a side, so I know these triangles are congruent, and I just need to figure out, is the side I know between the two angles or not between the two angles? In this case, it is not. All right, go ahead and try this one on your own, and then we'll go over it. All right, guys, hopefully you were able to get this one on your own. This one wasn't too bad. So we're given that S and U are congruent, and they're marked, and then RS and VU are congruent as well, so they're marked. So I'm given an angle and a side right off the bat. When I look at this figure, and you guys should start seeing these things, when you look at this, these vertical angles should pop out at you. Anytime you have vertical angles, that's kind of a freebie. So I could say these two angles are congruent by the vertical angles theorem, and then notice I have an angle, an angle, and a side. I have an angle, an angle, and a side. The side is not between the two angles, so I can say the triangles are congruent by the angle, angle, side theorem. All right, here's this last little chart to kind of help guide you. All these are possible congruence theorem, except side-side angle is not a thing, and angle, angle, angle is not a thing, And don't forget about the hypotenuse leg.